Today in class we started doing multiplication with the area model. However, what's different for 5th graders, unlike 4th grade, is that the expectation is not for students to simply find an answer, but to also use the powers of 10. What I mean by that is a number and an exponent. Base number, exponent. These are the powers of 10. What we're learning in class today is that this means 10 times 10 times 10, which the students interpret as equaling 1,000. So they need to be able to use this idea of powers of 10 within an area model. Let me show you exactly what that means. If we were to do the problem 42 by 56, students would draw a rectangle and expand the numbers into their place values, 40 and 2, 50 and 6. Now what's different in 5th grade is that instead of simply writing the answer, I am asking students to expand the numbers by their place values. So 50 would turn into 5 by 10. 40 would become 4 times 10. What we discussed in class today, when we do mental math, we do it in 2 steps. The first step is doing the multiplication fact. In this case, it would be 5 by 4. Now, we all know that 5 by 4 equals 20. The second step is actually doing the powers of 10. This may be the new thing. Students and adults alike already do this naturally, but they probably don't put it into number form. First, we take this 10 and this 10. And what we used to say is we would add zeros. And we know that's not really true. What we're actually doing is multiplying by 10 2 times. So we write 20 times 10 squared. If I go down to the next box, that would be 40 by 6. That becomes 4 by 6 is the multiplication fact. And then only times 1 10. 40, this 4 is in the tens place. The 6 is in the ones place. So it becomes 24 by 10. Many of the students are pretty oriented on just getting an answer, and that's not really what my goal is. At the end of class today, we were looking at a much bigger problem. I think it was a 3 by 3. I'm just going to make up some numbers here. And I'm not actually going to do the whole problem. I'm just going to do a little snippet. That would be 310 and 2, 456. We could do this mental math, 300 times 400. I know that answer is 120,000, I think. Is that right? 1, 2, 3, 4. Yeah, 120,000. Because I do it in 2 steps. First, I do the mental math, 3 by 4. And then I'd use the powers of 10. Now, we used to say just count the zeros, right? Well, that's exactly what I want the kids to do. But just to understand that I'm not just placing random zeros at the end of the number, but because I see 4 zeros, that means that the number, the digits 1 and 2, have actually moved over to the left 4 place value columns. So instead of simply being 12, they become 120,000. By the end of the class period today, the kids knew how to find the answer. That part they were good on. Like, for example, if they did 50 times 300, so many of the kids knew to just put 15 and then put 3 zeros behind it. They got that. But what they were struggling with is the idea of taking this and going one step backwards and saying, I know that that's 3 times 5 times 10 to the 3rd power, because that 3 is in the hundreds place. And this 5 is in the tens place, which means I'm going to multiply it by 1,000 later, or 3 powers of 10.